Okay, I mentioned standard deviation and now we're legit doing standard deviation, okay? Get ready for this thing. So standard deviation is based on the deviation about the mean. That's the key here. It's what's happening around the mean. What we're saying is how far away from the mean that is. That is standard deviation. All right, so standard deviation tells us how far away from the mean we are. The larger the standard deviation, the more dispersion. And what did we talk? We just talked about dispersion, right? So that's how far away from the mean that we're looking at. How spread out is my data? The higher the standard deviation, the farther away it is from the mean. It's more spread out, more dispersed. All right. This, ladies and gentlemen, is a tiny little statement that carries a whopping huge big punch. All right? That is the concept behind standard deviation, and that is what you need to know. All right? Okay, just like anything else, you're going to have population standard deviation, and you're going to have sample standard deviation. You're going to have different variables that go with each one of those. And so then we're going to talk about it. Now, notice I'm going to just jump down to this little statement right here. We are going to use technology, specifically StatCrunch, which is what I'm going to show you, which if you can see around the edges here of the computer, then you can see that little grid down at the bottom. So I'm going to be swapping back and forth between my iPad and the StatCrunch so that you can see how this looks on a computer because my iPad doesn't do it very well. Okay, so population standard deviation. I'm going to show you the formula. However, let me go, oopsie daisy. Let me go blue on it since I have blue there. The Greek letter is what we're going to look at first. So remember, we already talked about uppercase sigma, which looks like that great big E means sum. This is lowercase sigma. It looks like an O with a little line at the top of it. That is lowercase sigma. So we'll say sigma, like the word I'm going to say is sigma. So sigma here is going to be your population standard deviation. So anytime you see that symbol, you know that's going to be standard deviation, and more specifically, the population standard deviation. Now, I'm going to show you this formula just because I want you to see how it is derived. So we're going to sum the data value minus the mean, and this is population, so we have mu squared over n. Capital N, and we know capital N is the number of data values in the population. This is how you would find standard deviation. We're going to use technology, and we're not going to go through this whole process, but it is a big process to get there. It takes a lot. And think about it. What is the whole concept associated with this? So we're not going to use this formula, but you need to know, because I think this talks about it first. My data value, how far away is that from the mean? Boom. What is happening and the concept associated with it is exactly how the formula is dictated. You see that? So I'm going to sum up every time I have a data value here and see how far away it is from the mean, and then we're going to square that value. So when I do this subtraction, we'll square that value, then we're going to add all of those up. That's what you would do. Then you divide it by the total number that's in the sample, because it's always associated with how far away that is from the mean. So everything is related to that mean. Okay, for our, I'm going to go purple on this one. So our sample standard deviation is just the lowercase letter s. That stands for sample standard deviation. Anytime you see S, that's a sample standard deviation. And it is also a nice big formula here. We are going to sum up all of my values minus the mean squared over n minus 1. All right, and then that's our degrees of freedom we're going to talk about right now. So if I'm looking at this n minus 1, because this is a sample, right? My sample goes with the sample standard deviation. My population is based on the population values. This is based on sample values. So a degrees of freedom, this is a good definition of how you can look at that, is represented by n minus 1 because the first n minus 1 observations have the freedom to be whatever value they wish. But that last one has no freedom. It must be whatever value forces this sum, right? So as I sum that up to about the mean to equal 0. All right, so once I have all of them, then that is what forces that sum as I'm looking at it, which is why we have to have this degrees of freedom. We do n minus 1 to make it work closer with what it is that we're trying to find. All right, because remember, a sample, not a population. A population, I have all my information. We know it's completely accurate. Anytime you have a sample, it's not completely accurate with your total amount, but the bigger you can make that, the more accurate it gets, and then we work with that with our degrees of freedom. Okay, all right, so the sigma is population, S is sample. All right, now a variance. A variance is something that we're going to just briefly talk about right now, but there's more to come about variance later. Later on in the text, we're going to spend a little bit more time with variance and really show how that plays out. However, your variance of the variable is the square of the standard deviation. So the population variance would be sigma squared. The sample variance would be S squared. All right? Okay, and then there's more to come about variance as we progress through this section, but right now we're just laying the groundwork so that we can make sense of it, right? We're laying the groundwork. Do you know how to do these computations? That's the key. That's what we're looking for here. All right? Okay. So we are going to compute the standard deviation and the population variance, all right, of the test scores in Table 8. So now remember, Table 8 is everything. This is our population of test scores right here in 8. So what you would do, and I'm going to scoot this over, that's why I have this up on my computer. What you will do is on your homework, oops, sorry, I meant to do one more thing first and then come back to that. That's StatCrunch. We're going to use it. In your homework, you're going to have a little box up here in the corner, and it's going to look like a little double box, like an overlapping box. You're going to click on that box, and then it's going to be a drop-down menu. And the very first thing in the drop-down menu says Open in StatCrunch. And then you'll open that in StatCrunch and it will import your data. So for us to save time, because these are notes, I went ahead and typed in these values because these are the test score values. All right. And so in StatCrunch, and StatCrunch is something that you can get to from your homework. There's a place in your homework where you just click on at the very bottom of the screen and you click on StatCrunch and it opens it up. Or you do it like where I said, from that box. It's already embedded in your homework. See, this is the Pearson logo. It's already embedded in your homework. And then you're going to use these steps. All right, so once you have your data values in there, and it'll automatically import in, here are the steps for StatCrunch. You are going to click Stat. Everything we do in this class is going to be under Stat. So it's Stat, then Summary Stats, and Columns. All right, so under Stat, you're going to do Summary Stat and then Columns, and then it'll pull up this window. Our information is under var 1. So we're going to select that column so we know what data it is that we're working with. And then over here, I've got this huge list of everything that it can do for us. We want to make sure, All right, now here's the deal. I can click on one thing and it only does one thing. And then I can click on the next thing and it only does one thing at a time. Well, that gets old, right? I mean, we're trying to find the standard deviation and the variance all in the same deal. So I'm looking at this. Notice, I want to point two things out. Sorry for all the moving back and forth. See how this says variance and standard deviation? Okay, look down here. This says unadjusted variance and unadjusted standard deviation. I hold my shift key down to click on that so it selects two things. Unadjusted is population. So we had that degrees of freedom where we have to adjust it in the formula for standard deviation, right? Because you're adjusting for a sample. If I want population, it doesn't use the word population in StatCrunch. It says unadjusted. Unadjusted means population. And then you come down here to click compute. Now I'm going to pull this over here and I'm going to see if I can make this a little bit bigger for us so that you can see it bigger in your screen. Nope, it's not letting me. So do you see this right here? 96.4 and 9.818 as you go through here. That is the unadjusted and the unadjusted. Now I want to show one more thing to you here. So back under stat, calculator, summary stats columns. I'm going to go with the var1 there. And I want you to see what it looks like, standard deviation all the way through unadjusted standard deviation. It's going to give us a whole bunch of stuff that we don't need here, right? That's not the point. The point is I want you to see, look at this standard deviation. This one is 10. It's not letting me, oh, it is letting me select it. 10.34. Is that the same as my unadjusted standard deviation over here at 9.81? No, because this one adjusts for the degrees of freedom, assuming that this is a statistic, right, from my sample. Ah, you see where I'm getting at now? It does make a difference if it is a population versus a sample. So if I pull this back, I also want to point out these formulas. Look at our formulas right here. This is capital N. This is adjusted. This one is unadjusted in StatCrunch, and this is just a regular standard deviation because most of the time we work in terms of a sample, right? Rarely do we actually get the joy of working with a population here. All right, I'm going to write our steps down here, our StatCrunch steps, just so that you have them in your notes. I'm sure you've already done it because you're amazing students, but I just want you to see what this is, StatCrunch steps. You're going to click Stat. Then you're going to click, did you see what it was? I thought maybe I'll try to do two on here at the same time. So if we go to Stat, oh dang it, it won't let me do it. Summary, stats, and columns. I was hoping I could put both things up there at the same time. Doesn't look like it's letting me. Oh, look at that. Stat. Just so you can see where it is as we're writing these down. Summary stats. And then that leads us to, oh, it went away. Columns when I started writing. So I guess that really didn't help. All right, but whatever. That is where that information is. So I'm not going to expect you to go in here and do these formulas. All right. Woohoo, woohoo, woohoo. But I do want you, these formulas are so helpful to understand, hey, this is about the mean. This is adjusted, right? All of that makes an impact when I'm talking about the sample. Now, I do expect you to know that the sample standard deviation is an S and the population standard deviation is that sigma. All right? So this asked me to find the population standard deviation, so you have to use the right symbols that makes an impact. And so your population standard deviation is 9.818, and your variance is 96.04. You can pull that, I'm going to scoot it back over here. You can pull that over here on this side because it's unadjusted. I wrote the wrong thing. 96.4, not 04. That's my bad. I meant to put 40 and I just messed it up. So 9.818 is rounded, and then 96.4. Sorry, I wrote the wrong thing. That's my bad. And honestly, I don't know why I tried to put that 0 at the end of it. It's just 96.4. All right. Okay. So here's the other thing that happens with this. 9.818 points, because that is legitimately what it is. Those are the points. That's a standard deviation. So if I'm laying out my data, I have my mean value, and then this is spread out. The next standard deviation is 9.8 test points, right? That percentage points away from the mean. That's that dispersion. That's what I'm talking about. How far away from the mean am I going? Well, every standard deviation that I'm talking about here is rolling 9.8 points away from the mean. 9.8 points to the right and to the left. And your variance, because it is squared, so is your unit. So your variance is 96.4 points squared. And again, we'll talk more about that as we get into it a little bit more. I just want to make sure that for right now, you can kind of see what's going down with this. Okay, standard deviation is a big deal, so I want you to own this a little bit. Finding it in StatCrunch, that's going to be on you, making sure you remember how to do that, so make sure you're practicing it. I'm going to scoot this up a little. Now, we not only have to do population, but we want to do sample. And so I want to make sure we're looking at sample. So notice I have these values over here to the left still. I left them up there on purpose because I want 5, 10, 2, and 6. That same sample that we had talked about in that last section. So if I'm looking at just my sample values, 5, 10, 2, and 6, 5 is 62, because you can see that right there. 10 is what? I lost it. 88. 2 is 77. And 6 is 68. So these are my values that we're looking for here. I didn't type these in already because I just wanted you to see what it was. So if I go here to list 2, I'm going to type in just on my keypad 88, 77, 68. Then whenever, I don't need this one anymore because it's going to be different because I'm going to be looking at 2. So same thing, stat, summary stat, column. You literally go the same place every time. But I only want the second column. And whenever I'm up here trying to figure this out, I just want my variance and my sample standard deviation for this one, and then I click compute. I'm going to roll this over here so we can see it better. It's finding it exactly the same way. So this is a sample standard deviation, so I'm going to use S, and that is 11.325. Oops, I forgot my 3. 325. And again with the points, because it's a standard deviation, my sample variance is 128.3. Points, well, you know what, 25. It's already in there. Why am I trying to round that? I don't know. Points squared. That's the key. You're going to find this the exact same way that you do the other. You have, let me scoot this down. Stat, summary stats, and columns. Oops, sorry, let me scoot this over so you can see everything that's going on. Stat, summary stats, and columns is where we're going with for that. Okay, all right, so I'm going to scoot this over so that it becomes the main screen again rather than StatCrunch with my iPad. All right, so I'm going to scoot this up because we are going to reiterate this because I'm telling you right now, if you don't get anything else out of this, I need you to get this right here. Standard deviation is based on the deviation about the mean. How far away are we, right? The larger the standard deviation, the more dispersion the distribution has. Means more spread out it is. So here's my question to you. The larger the standard deviation, the bigger the number is. What does that tell you? Yes, the data is more dispersed. The data is more spread out. The smaller the standard deviation, what does that tell you about your data? Yeah, you squeeze that in. It's much tighter. The data is closer together. It's all clustered around that mean, that same value that we're all looking for, and it's all based off of the mean. So how spread out from the mean or how close to the mean? The smaller the standard deviation, the closer the data is to the mean. And that's really what I want you to get out of this. All right, that's standard deviation. How far away from the mean? The mean is the key to this whole business. All right. Okay, so this is a small set of data, just those tiny little test scores, little 10 test scores. What if I have a big set of data like on that University A and University B situation, right? All right, so I'm not going to type, why did I just write that? University A and University B, right, that we were looking at before. So I'm not going to try to type all of those in, those IQ scores in, right? I'm just going to go with this. And so I'm telling you that the sample here is 16.08 and the sample standard deviation is 8.35 on those scores. So that's how I'm looking at this. So my sample standard deviation, that's an S. I'm not going to write all those words out. That's crazy talk. S, sample standard deviation for University A and University B. Now here's what I want to know. We want to use these values to determine which one has more dispersion. There's that word again. You tell me. Yeah, University A, you guys are so good. Why? Because the number's bigger. That's it, right? University A has more dispersion because it has a larger standard deviation. It's more spread out, more dispersed, has a higher standard deviation. Now, can we come back over here and just say, thank you, Captain Obvious? Did we not literally already talk about that? Oh, yes, we did. This is just another way. So we saw the histogram, and our histogram showed us our data was more spread out. We saw our histogram, and our histogram showed us that data was tighter together, closer to the mean. How else can we figure that out without having to make a graph every single time? Because that gets cumbersome, right? So in lieu of making a graph every single time, we just have to know what the standard deviation is. And if we can pick up on that standard deviation, that tells us how tight is my graph, how spread out is my graph, right? Standard deviation is a big deal. It's a big deal, and that's a huge concept in statistics. So grab a hold of that because we're going to hang on to it for quite a while.